Okay, in this session, we're going to talk about downforce as it pertains both to Delta Force and the Air Force. We'll kind of talk about both. So first, I want to define, we'll talk some here first about ground contact and margin. So at first, I want to define what margin is. So what you see on your home screen as it pertains to the ground contact and margin is an average of the last 3 seconds. So we draw a graph, and this is time down here. We have 1 second and 2 seconds and 3 seconds, and we have pounds over here, 50, 100, 150, 200. That would be a weight pin reading that the 2020 would see. So you can say, well, in 3 seconds of time, the average is here. That's the value that would be displayed on your 2020. Margin is the lowest reading that weight pin has seen in the last 3 seconds. So this number right here is margin. So margin is the lowest number, so everything else is really above the margin number. So the way that's engineers kind of built it is so that it errs on, you're always erring on the more weight rather than less weight getting put and applied to your gauge wheels, because shallow planting seeds is more costly than excess compaction most of the time. So that number is margin. And this is what Air Force controls to. Air Force controls the margin. Delta Force does not control the margin. Delta Force makes 5 changes per second, or it can make 5 changes per second. So in 3 seconds time, at 5 changes a second, Delta Force potentially made 15 changes in 3 seconds. And so margin is sort of old news or old data as far as Delta Force is concerned, because it's changing so rapidly. Air Force, on the other hand, and it's built into the software to do this so that it's not burping and pumping air constantly all the time. It intentionally takes about 3 seconds for Air Force to decide that it's time to make a change. They could try to make it respond quicker, but you would be using up too much air and it really wouldn't be practical. So Air Force will make a change about every 3 seconds. Delta Force, and that's a planner-wide change for Air Force. Delta Force is making 5 changes per second on a row-by-row basis. So we're going to switch over here now and show a few field or kind of explain this on the simulator and also on the iPad. So here we are on the simulator and looking at the downforce box here. So we have margin. That's going to be the average of all your active pins averaged together. Ground contact, right now it's at a stopping point in the simulator, but ground contact is, we want to keep at or near 100%. So 99, 98, 100 preferably. But if you're running 90% ground contact, that means that 10% of the time there's no measurable weight on the gauge wheels. So you're almost guaranteed then to be shallow planting. The 2020 doesn't really know, but most likely you're shallow planting if you don't have any weight on the gauge wheels, your planter unit's riding up out of the ground. We want to keep that number 99 to 100, but minimize margin. So we just talked about the technical definition of margin. Kind of in simple terms, margin can also be thought of as the extra weight that can be removed from the row unit without losing ground contact. So we like to see margin generally in that 60 to 70 pound range. You know, you need some extra weight on your gauge wheels. You can't have 1 pound of margin, would be way too risky. You need 60 to 70 is a good target number to carry. If you're up over 150, like 150 pounds of margin is most likely causing you or is costing you money unless it's really, really cloddy or dry conditions or something of that nature. But minimize margin, but maintain 100% ground contact is kind of the target there. And I'm going to click on Downforce here. Same would be true for Air Force. Would be you set a number. You can click on it and type it in on a Gen 3, or on the Air Force system, it's a range, and you can go to custom and move that range up and down as needed. So first day, first field, first pass, I always set my target for Downforce on 120 and then make adjustments from there. So the proper way, or the true way to set or know where to set your target on Downforce is actually through field view. And we're going to switch over to my iPad, and I'm going to show you what I mean by that. I generally don't like to make any changes, whether that's depth or closing wheel pressure or downforce when you're planting end rows. That's generally not a good idea. You want to make the changes you feel are necessary once you've evaluated it out in the infield of the field. So we're going to switch over here and show a little bit on the iPad. Okay, this is a little bit sketchy of a shot here, so I apologize in advance for the blurriness or whatever, but here we're looking at the iPad, the Downforce map as we're simulating planting here. And so what I like to do once you've planted the end rows and you started in the infield is periodically, with the Downforce map active, whether that's in a split screen format or like we have here, is hit this reports button here. That'll generate a downfield or Downforce field report. And so you can look at your loss of ground contact, good downforce, and excess totals down here at the bottom. And so you obviously want the most in the good category, but then I generally like about a 4-to-1 ratio. We want to err on the excessive side here and minimize the loss. If we're running, say, 95% good, 4% excess and 1% loss would be about a perfect distribution, from my opinion. So that's kind of what we're shooting for.
but let's say you planted half the field and you make a change to your downforce, you increase it by 10, 20 pounds or decrease, whatever. But these numbers are going to take a long time to change because you're averaging in the whole rest of the field that you've already planted. So that's where this slider bar up at the top will flip over to instant. And after 10 seconds, this will populate because this instant is a 10-second rolling average. And so, if you make a 10-pound adjustment, you flip that to instant and you start planning, and after 10 seconds, you can see your totals down here to see if that was a positive change or a negative change, and adjust again to try to get, you know, the most into the good and the 4-to-1 ratio between the excess and the loss. And I'm sorry if the numbers don't jive here because of this a demo, but that instant slider bar at the top is the proper way to use the iPad to set your Delta Force target and know that you're doing the best job possible. Okay, I'm gonna show the filter, where the filter is on the Delta Force master block. It's that large nut that's kind of in between those two hoses right there. I'm gonna point to it. Right there, that large nut. If you take that and loosen it, behind that is a filter. That is a 5-year service item for Delta Force. And there's also an anti-rotation bracket that's around that nut to keep that from loosening. And those anti-rotation brackets are provided at no charge. All the new blocks come with that pre-installed, but for the first several years, that was not a factory installed item. So they are available because what can happen is that nut can loosen up over time from the heating and cooling of oil day after day after day. That nut can loosen and blow the O-ring that's behind it, and it sprays oil absolutely everywhere if that happens. So that nut is to keep that from doing that. If you bought a used planter, or if your planter doesn't happen to have that retention ring on there, please let me know. I've got a few extra here on the shelf for anyone that doesn't have that. And again, that filter behind that's a pretty large nut, 2.5 inches or something like that wide. Behind there is the filter. You can replace the O-ring if you want. It's a $9 O-ring that goes around that behind that nut, but I guess as long as it looks like it's not damaged, you don't need to. That nut is torqued to 200 foot-pounds from the factory. If you try to retorque it to 200 foot-pounds, you'll probably bend the bracket that it's bolted to. So the fact that we're putting the retention ring on there, just get it as tight as you can, and then put the ring on there should keep that nut in place. So that's a little bit around the servicing of that Delta block. And here we're showing the ram of a Delta Force cylinder. So for those of you running fertilizer on your Delta Force planters, if you happen to splash fertilizer on the ram of the cylinder, it needs to be wiped off pretty much right away. As soon as possible, wipe the fertilizer off that ram and re-oil it with a thin coat of oil to keep that from rusting. What will happen is that ram rusts. It will score the inside of the seal internally, and your Delta Force cylinder will begin leaking, and the only way to fix it is to replace it. So fertilizer on the ram is a bad thing. if you get on it right away, you can save the cylinder and keep it operating correctly. Okay, back to the simulator here. So this applies to Air Force or Delta Force. You can zero the, or I guess the system without active control, just any way pin would be, you can zero the load pins. I would recommend doing this really as often as you want. There's no reason not to, I guess. Once a day for sure, even once every time you fill up the seed would be fine. By tapping on V drive. Let me try that again. No, it's not going to work. Sorry. Need to be tapping on Delta Force, and then load sensor calibration. Zero all sensors, and the same is true on a Gen 2 with Delta or Air Force. You got a zero all sensors button, and you got to make sure your planner's raised and there's no weight on the pins. But you zero them all, and away you go. So if you've got a load pin that's acting up or you suspect is faulty, make sure you do that multiple times. And if it still pops up relatively quickly as being faulty, the best thing to do would be to actually move that way pin to another row and make sure that it follows the way pin. That is a little bit time consuming, I understand. Way pins aren't the easiest thing to just swap out. But that is the bulletproof way, I guess, to make sure that the faulty signal follows the load pin and doesn't stay on the row, and that it's something else on the row, either mechanically or the wiring or something like that. Couple other things on Downforce. So Case IH owners or red planners with, or I guess you can have reduced inner diameter tires on green planners too, or any color planner. You can buy reduced inner diameter tires, gauge wheels. They need to run an extra 50 pounds of Downforce over and above standard tires, because that relief that's created on the inside of the tire right next to the furrow is rather risky. I'll just say it's rather risky, because especially if you're controlling your downforce with active downforce like we do a lot of times now, you can actually leave the sidewall too loose, like we kind of talked about in our furrow creation, or understanding the furrow and our furrow creation segment, that if the sidewall is too loose, it will actually crumble and you can get dry dirt fall into the furrow before your closing system actually gets it closed shut correctly. You end up with dry dirt around the seed, which creates uneven emergence. So an extra 50 pounds for reduced inner diameter setups is what you're going to want to run. So if I'm running 120, Case IH user is going to be wanting to run 170 for downforce target. One other thing I'll mention on downforce is around hydraulic pressure. So I've said this in a few of the other sessions here today, but I've seen it already this year once and in years past, where the return line on any hydraulic function, whether it's downforce or fertilizer pump or vacuum blower or whatever, that return line can get, the tip where you plug it into the tractor can get blocked or partially blocked. And so just because you have oil pressure doesn't mean that there's oil flowing through the return back into the tractor. And so usually you can just flip the lever backwards for a second in the cab and then go back forward again, and that gets the flow of oil going. In really bad case, one time that didn't work. We tried it multiple times. Finally, we had to crack the return fitting, the tip on the hose, and bleed it off manually. It was under a lot of pressure, and tightened it back up, and away we went, and that fixed it. So just be aware that it is possible. I've seen it multiple times where you can get the return tip blocked on your return hoses.